Good afternoon, good morning, wherever you may be. Welcome to this August meeting or July meeting, almost August meeting of the Virtualization Virtual Group. We will be meeting the next 2 weeks in a row. So if you didn't see, Anthony's going to be back with us next Wednesday also. So go ahead and go register for that particular seminar too. So real quickly, we'll go over some past news and then we'll hand it over to Anthony. First of all, the community call for the speakers were announced. So if you want to go find out who's speaking at SQL Pass and see what their sessions are and stuff, feel free to do that. You might get to come and listen to me because I'm speaking also there this year. So I hear that in a couple of weeks we'll actually have the schedules, so you'll be able to look and see what it is. So if you're not going to Pass Summit, go ahead and sign up. You can save $150. If you'll go to the virtualization.pass.org website, you can get our code to get $150 off. It is a great time. A lot of great content, great people come there. Past marathon, we'll go ahead and skip because we're not going to be doing the Portuguese edition. There are also other virtual groups that are upcoming. So if you not aware of it, there are like many different virtualization groups that you can actually listen to and hear. So, and then of course there's all the different virtual groups. So go sign up for the ones that you want, that you care about. SQL Saturdays, there's many SQL Saturdays. Several of them have already happened. But you can see Salt Lake City's coming up this weekend. Sioux Falls is coming up. Just go to SQLSaturday.com and you can see all the SQL Saturdays around the world. If you're looking for a new job or you're looking to find someone, then go to pass.org careers and you can find the other information about jobs. And also as a member of PASS, you can basically connect with them via Facebook, Twitter, LinkedIn, and all the different ways. So today we have Anthony with us. Anthony, I met him last few SQL Saturdays that I went to speak to. He is probably one of our foremost authorities on containers at the moment. There are a lot of us trying to get up to speed, and we'll continue to bring you some great content on containers and trying to get us all of our feet wet and what they are and how we can use them. So at this point, I'm going to hand over the presentation to Anthony. And once again, thanks, Anthony, for coming, and I'll let you introduce yourself further.
Cool, thank you. Let me just make sure I'm sharing the right screen. Show my screen, looks good. Yeah, so awesome. Well, thanks for having me, Tom. I appreciate it. This week's session, we're going to focus on kind of like big picture concepts in Azure. And the next week's session, we're going to look solely at SQL Server and containers, but both sessions kind of stand alone, but just kind of set the bar and what we're going to focus on today. So today will be apps and containers in Azure, and next week will be SQL Server specifically in looking even on-prem or in Azure, however you want to deploy that. So let's get cracking. So this is practical container scenarios in Azure, and I'm Anthony Nocentino, consultant and trainer and founder of Centino Systems, where I specialize in system architecture and performance. Been a data platform for a little while. I got to update that slide. I was recently renewed a few weeks back. And there's also my contact information. If you need to reach out to me, have any questions about today's session or anything about containers, SQL Server on Linux, things like that, go ahead and reach out. If you're not following me on Twitter, please do so. It's kind of my main way to get information out to the community on things like blog posts. I blog relatively frequently, kind of getting that new cutting edge content out there, like Tom said, about containers and SQL Server on Linux and things like that. I'm also a Pluralsight author. If you want, I can kick over some free trial cards to you if you want to get into any of the content that I have available there. You can get via email if you're interested in that. So let's talk about what we're going to talk about today and set the agenda for the things that we're going to go over. We're going to start off with some container fundamentals. Again, I want these sessions to kind of stand alone. So if you've never used a container before, that's cool. You're going to learn what it is, and then we're going to learn how to use it. We're going to kind of jump into the deep end of the pool and create our own container today. We're going to take an application, We're going to put it into a container and run it on our local machine. Once we're done doing that, we're going to learn how we can take that container, pick it up, ship it into Azure, and then use that to deploy our application in Azure Kubernetes Service. Now, all of that stuff is a lot of tech, right? We have containers, container registries, and Kubernetes. All of that we're going to cover today with lots of demos, some pretty good slides, and some illustrations to kind of get you up to speed on what a container is, what a container registry is, and what Kubernetes is, and how you can use that to roll out applications in your data center. So let's talk about why. Like, why do we even consider using containers to containerize our apps or deploy applications into our data centers? The number one reason to do this is this: reducing development time. We can take applications from developers' workstations and get them into production faster. And what that means is that provides value to your business because features for your application, requirements, whatever it is, can get to production faster, which means you can do whatever you do for your line of business more quickly, more effectively for your customers, right? Number one reason, reducing development time. With that though, there's infrastructure to help us with deployment automation, right? So now we have this ability to reduce development time because we can take these things called containers and push them into prod really quickly. Well, we need some ways to do that automatically. We need to do it fast and we need to do it consistently, right? Take that stuff from development, get it into prod fast. And so we'll see things like DevOps or CI, continuous integration, or CD, continuous deployment scenarios, right? So this is kind of that whole ecosphere of DevOps and CI, CD, buzzword bingo, to get apps into prod. And so continuous integration, roll it out into code, continuous deployment, getting it into production, right? Kind of building pipelines to automatically do these things, right? Roll code out, get it into prod, and get that stuff into production. Now, these are the reasons why. We're going to focus on how as we go through today's session. But this is another thing that I want to drill home today too, is we need to rethink how we deploy applications, right? We're not really going to focus on the server anymore, right? We're not going to really focus on stuff like PRD SQL 001 or apps 01 through 10, whatever those server names that we used in the past. We're going to develop services, and the platform is going to run the container for us and expose those services to be consumed in our applications or by our end users, right? So we're going to rethink about how we deploy applications in our data center. It's going to be the application service and not the server. We're going to talk about the tech on how we make that happen throughout the session today. So if you've never seen a container before, let's kind of go through that concept real quick. You're going to see this picture a couple times today where we have a container, right? And a container contains an application, right? And what does an application contain? Well, the binaries and libraries that support the execution of that application. Now, a container itself really functions on operating system virtualization. We're kind of used to the concepts of machine virtualization where we're exposing things like CPU, disk, and RAM. We put an operating system on top of that, and that's how we deploy apps in machine virtualization. In OS virtualization, what we're doing is we're subdividing the OS itself, right? We're going to share the kernel and the system resources in our server or in our operating system itself. What that means is we can stand up all applications, isolate them, and they can execute independently with each other. And that's going to be important. We're going to learn about why as we go through today's session. So like I said, what does a container contain? Binaries, libraries, and also the file system components that are needed by our application. So if there's anything like configuration, any data or anything like that could potentially be stored inside the container itself. Generally speaking, we're going to have one application inside a container, right? We'll generally run one app that's going to live by itself because this is going to be the unit of work that we deploy in our data center, right? It's the application that's going to stand up. We're going to run an app, whether it's SQL Server, a web application, or whatever that is. One key facet of containers is that they're ephemeral, right? They kind of don't really exist with state over time, right? That's like the exact opposite of what we do as DBAs, right? That's our sole function, is to keep track of system state over time or to protect the data in our applications or in our databases. In the container world, the container is ephemeral such that it always goes back to a starting point when it stops and restarts. And we're going to learn about how we can add some persistency to our systems today and a little bit next week. But this ephemerality concept actually is quite liberating in how we deploy our applications or even databases. We decouple the configuration and state from the actual service itself, and we can inject that externally. Again, we're going to learn about those techniques over the next 2 weeks. So kind of zooming back onto what a container is. So let's say we have a physical machine or even a virtual machine. When we deploy a container or we want to build the system to use a container, we just install a host operating system. And that host OS is going to have particular pieces of functionality that allow us to subdivide the OS itself or virtualize on the operating system. So you can deploy applications independently of each other. And so here we see app 1, 2, and 3 that could all potentially be executing inside of containers on top of this host operating system on that physical machine. Now, app 1 and app 2 don't know of each other, right? If you look at a process listing inside of those containers, they won't see each other. If they need to communicate to each other, they'll simply do it over the network, right? Now, this concept is really liberating in the sense that if you ever were a developer and you deployed application 1 with a particular framework or a particular library or DLL, and that conflicted with app 2, well, what did you do? Well, you had to put app 2 on a different server, right? In the container universe, I can deploy them together on the same hardware because those files or resources are contained within the container itself. And so they won't step on each other's toes from a DLL standpoint if there is a conflict between those two applications. And so the execution of containers in this context here, they're completely independent of each other. Again, for app 1 to talk to app 2 has to happen over the network. Now, from a container standpoint, if I need to make a change, right, and this is where the ephemerality of containers becomes interesting, I'm going to simply kill my container and redeploy it, right? If I need to upgrade application 1, patch it, I need to make a code change and roll out new code, I'm going to kill that container and redeploy it because of the state of that application will be stored externally, right? If I'm always going to go back to a starting point of just standing up the container from its original container image, then having that be stored externally is how I'm going to maintain state over time. Again, we're going to focus on the techniques a little bit later. And so what do containers bring to the table when we're deploying applications? The number one thing is speed. When we talk about deploying containers, and the container that we're going to build together today, I think lands somewhere between 50 and 70 megabytes, right? And for me to deploy that application, I can roll that out very quickly in a data center on a high-speed network. 70 megabytes is a trivial amount of data to move around. Even something as big and monolithic as SQL Server lands at about 1.3 gigabytes to deploy SQL Server as a container. And so to roll that out, I can do that very, very quickly in a modern data center. Containers also give us the ability to patch, right? We discussed the concepts of killing our application and redeploying it. So if we have to change something in that app or patch the application itself, well, that's very, very easy to do. And we're going to learn some of those techniques today. Troubleshooting gets to be a little bit interesting in the container universe in that, well, if that application's not functioning well, what's the fastest way to get back to my application back to service? Well, I can kill the application and redeploy it. And so our troubleshooting methodology becomes a little different because that container state will go back to where it was when the container was created. I deploy it and I apply the configuration externally and I get my application back up and running. Upgrades become a lot easier as well because we've decoupled the components in our application. We'll learn next week how to upgrade SQL Server, and it's going to be very, very easy. I basically kill SQL Server, restart it with the new version, and I've upgraded my database engine. Very, very liberating there. And then finally, fast and consistent deployments. As we start building pipelines to roll out code, we're going to do this very, very quickly, and we can do it very, very consistently, which is the number one reason why we want to do this, fast and consistent deployments. And again, I'm going to beat this point home, services, right? We care about services, not the servers. As long as we have a container running and our users can access the application that's in that container, we're providing the service, right? Because this container thing is going to be ephemeral. We can start and stop those on demand as needed. Now let's talk about getting or creating containers, right? Kind of talked about the concepts and things like that. Let's talk about like how we're going to get things done now. So you might have heard me use this word a couple of times. I tried not to let it slip in there, but it slipped in once. Images. A container image is the code, the runtimes of the libraries, and also the environment variables for my application. We're going to build a container today, and all of that stuff you're going to see pieced together. But it's literally my application code compiled, any additional libraries or runtime things that it needs to run that application, and the environment variables to run that app. And so that's one of the ways that we can assert configuration into our applications is using environment variables. I can inject those when I start up my container and tell that and affect change on the execution of the application running inside the container. Container registries are where images live, right? You might have heard of the term Docker Hub before, or Azure Container Registry. That's where we take our container and we store them for use for consumption by our applications in our data center. We can also build our own internal container registries if we need to do so. A Docker file is what defines the container image. We're going to build a Docker file together in our demonstration, but that thing basically tells Docker or the container runtime how to execute this particular container. We're going to build one of those in a little bit. And to kind of walk through the pipeline, we're going to create an image by defining a Docker file that builds our application inside of the container. Anything that's required, like the binaries or libraries that we need, we then tell Docker to build this application or to build this container. So we define a Docker file, we tell it where our apps are, and we literally say, Docker, build a container. So that creates a container image on our local machine. Once we have that container image on our local machine, we push that container into a container registry. When we want to consume that container, we pull it down to a host operating system, and then we run the container on that host operating system. And so that's kind of the pipeline, that very linear pipeline of how we're going to get code from our developers to production very, very quickly. There's a couple orchestration pieces that we'll talk about later on, but this is kind of the core pipeline that you'd use, or core process that you would use to do this. You build, push, pull, and run. Now, if you're using your own container or building your own container, you're going to do this whole process. But if you're consuming containers from Docker Hub by someone that's published a container like Microsoft, you're going to focus on the pull part. So basically, Microsoft is doing the build and push, and you're doing the pull and run to get that container up and running. So let's look at what a Docker file is a little more closely. A Docker file describes the commands to build an image. And so with our container, I told you you're going to see this image a lot. In a Docker file, we're going to say something like this. Let's go ahead and bring this all up at once. So we say from mcr.microsoft.com. In this case, I'm going to use a .NET Core ASP.NET web server or container. And so what I'm going to do is I'm going to start my build process from something that Microsoft has already published, an ASP.NET container image. And so with that, I can go ahead and copy my application into that container. And that's what the next line does here. It says copy this web application that we're going to build together today into the container and define an entry point, which is basically the process that's going to start up when I tell Docker to run this particular container. Now, the key thing here is we're building off of someone else's work, right? We're literally saying from a container that Microsoft is maintaining for us. I'm defining a specific version here at the end where it says 2.2. That way, we don't have to maintain that piece. We can just take that from Microsoft, they publish that and make that available to us, put our application in there and go, right? And so again, that's less things that we have to worry about when rolling out our applications. We're going to get a well-built container from a container or from someone that's responsible for publishing a container, in this case, Microsoft, put our app in there and go, right? Before we'd have to buy a VM or buy a server, install an operating system, install IIS, get our app on there, publish it, push it, and do all of those things. This is crazy that we can do get this amount of functionality in effectively 3 lines of code. Now, any application that we're going to build today is going to have to be available over the network. And so we're going to say expose 80. And so when this thing starts up, it's going to listen on port 80. And so this all together is all we'll need to build a simple ASP.NET web application. And we're going to do this together today in the demonstrations. Once we have this code saved into a text file, we tell Docker, right? We talked about the flow a second ago, right? Remember, build, push, run. We say Docker build, we give it a tag, -t. I'm going to call this my web app image, and it's going to take that image from Microsoft, copy my code in there, compile my application, and go. And we're going to have a ready container to run in our data center. Now, building Docker images is very feature rich, right? This is a very simple example, but there are a lot of ways to do this because there are lots of different types of applications that have to be deployed inside of Docker. So go ahead and check out that link there if you have a more complex scenario that you need to run your app. Now let's kind of zoom in on container registries, right? We looked at Docker files. Let's look at container registries. They store container images, and they can actually be public or private. Like most of the time, we're going to consume container images from public registries, right? When I do that for Microsoft, I'm going to pull from their container registry that's publicly available. But we can also have private container registries that require authentication, or we can even run them on-prem inside of our own data centers. But that way we know if we have something that we don't want available to everybody, we can do that. But if we do need to open it up, we can and make it a public registry. They're also secured in a couple of ways. First off, transport. They'll be distributing their data over HTTPS for moving that between A and B, but they also maintain image digests or hashes of the image itself. If you think about what we did on the last screen, we said from mcr.microsoft.com and loaded an ASP.NET container and put our application in there. Well, how do I know someone didn't do something naughty to that container? This is how we know. The image digest is created by the publisher, stored with the container in the container registry, so that I know when I pull that container down, it hasn't changed. Because if you think about it, right, we're building our apps on top of someone else's work, which is great. Get all the benefits of that. But we do have to take into account is that thing really the thing that we think it is when we pull it from the container registry? Container registries wind up becoming kind of the key building block of a CI/CD pipeline. We take our containers, we store them in the registry, we pull them down, right? It's literally called Docker Hub for a reason. And that's going to be kind of the main core aspect of a CI/CD pipeline. Developers will build containers, stick them in the container registry. Ops people will pull them and push them into prod, or your pipelines will do that for you automatically. Images are categorized by tags. You notice a second ago, I gave my image in the example, my web app image. Later on, we're going to give it a specific version. I'm going to say V1, V2, and that gives me the ability to select different types of images when I want to work with them. For example, the ASP.NET container, you saw that I pegged that with a colon 2.2. I wanted a specific version of that container. We talked about Docker Hub a little bit, just kind of some examples of container registries. The Azure Container Registry, which you can build your own registry in. And there's also mcr.microsoft.com, which is where Microsoft is publishing their container images for things like PowerShell, ASP.NET, and SQL Server. So that's a lot of talking. We're going to shift gears into some demos and do this together. We're going to create a container-based application. We're going to build it and stick it into ACR inside of Azure Container Registry. So let's go ahead and shift gears here and hop over to my demos. I'll make both the decks and the demos available. I'll put them on my website and I'll give them to Tom to distribute to the group. But it's pretty straightforward from a platform standpoint. If you have Docker, .NET Core, and Azure CLI on your system, whether you're on a Mac like I am, Windows or Linux, all of this stuff should just work, hopefully. Well, with the exception of this command, because that's specific to my machine, because it's the path. So I'm going to use .NET to basically create an example, simple .NET application, basically the hello world version of a .NET application. I could do that with this .NET new command. What that's going to do is restore a C# project on my machine, and I'm going to call that my web app. So here you can see at the bottom there in the output, the CS project for .NET that defines this application that we're going to build together. I'm going to copy in a custom page that I wrote because there's some information that I want to expose specifically for the demos today. And that's it. That's the application that we're going to work with. And so let's go ahead and change into that application and run it so you can see what it actually does. Now, I'm literally just running this app on my system here. I'm not doing any container-based anything yet. We're just compiling the app and making sure it works. And so I'm going to go ahead and launch it on localhost 5000. It's going to load the application. You can see it's on localhost 5000. Simple web application spits out the system host name, which is my system's actual host name, Anthony's MacBook Pro, and the application version 1.0, right? Basic web application that we're going to run. Now let's go ahead and break out of that. We know our app works, just kind of a quick sanity check. Now let's make a container out of that. The first thing that we're going to do is compile it for release. So .NET publish -c release, just making sure that that's available for us to package. Now, let's go ahead and shift into making a container image itself. And so we talked about Docker build -t web app image, the same as we did in the presentation portion of today's session. We have a dot here for the relative path. So we're going to be pointing at this location right here, and we can see that the Docker file is in that location. So I do Docker build -t, my web app image, it's going to read that Docker file. What's inside that Docker file? Let's go check. what we talked about in the presentation portion of the session. So we're building from this container. We're going to copy in that application that we just built together, and we're going to tell Docker when it needs to run this application, run .NET and load this DLL and expose it on port 80. And so let's go ahead and do a Docker build. So now it's taking my app, my compiled application, copying it into the container image and building that container image. And we can see the different steps here that Docker build executes. It pulls the container if it wasn't there already, copies our stuff in, defines the entry point, exposes the data, and it built our image. And there we see successfully tagged my web app image latest. And so now if I do a Docker image ls, I'm going to get a listing of all of the containers on my system, but I have lots of containers because I work with them a lot on my machine. But here at the very top, you can see repository, which is, and then my web app image. It's going to be tagged latest. It gets a unique identifier, when it was created, and 265 megs in size. If I want to filter that off, I can use grep to give me a much shorter list if that's what we need to do to filter out our data between that large output that we have up there. And so different images that I have available, you can see PowerShell, there's the ASP.NET Core application, I have an Ubuntu image, several SQL Server images and things like that running locally. So now I have a container, but I don't have an application up and running. We just ran our application natively a second ago. Now let's run the containerized application. And we do that by asking Docker to Docker run. What are we going to run? We're going to run an application named My Web App. We're going to publish the application on port 8080, and it's going to forward the traffic into the container on port 80, right? We talked about expose in the Docker file, so it expose 80. So the application itself is listening on 80. I start that container up, but for users that I want to have come along, I'm going to send them to 8080, and it's the job of the Docker runtime to forward that request into the container on 80. We're going to run it in detach mode, which is basically going to background the container. And this is the container image that we're going to run. This is my web app image, which is the same thing that we just built a second ago. So Docker is the command, run is the thing that we want to do. We're going to name our application my web app. It's going to listen on port 80, and it's going to run this image. So let's go ahead and do that. We get an identifier back for our image. And if we go to this particular port now on 8080, we'll see something a little bit different than we did a second ago. When we ran it natively, it ran in Anthony's MacBook Pro. But now we're going to see we get this system host name is the identifier of the container. So here you can see 17C354, 17C354. This is executing inside the context of the container, and the host name is defined as the container's ID. So if I do a Docker PS, we can see that there's the container ID, there's the image that we're running, there's the command that's being executed. When it was created, the container itself, for 40 seconds ago, it's been up for 39 seconds. We can see that our container is listening on all IPs on this host. So anyone on my network or routable to this network can hit this application on 8080. And then that forwards into the container in the exposed port of 80, which is where our application is running. And our container's name is my web app. And so all of those elements together make up our running container. Now let's take this container and send it off to Azure, right? Because we're going to do some cool demos with Kubernetes towards the end of today's session. And we're going to take this thing that we just built and ship it into Azure. Let's go ahead and make sure that I'm pointing at the right subscription. Now, the first step I have here is to create a resource group. I've already done that because sometimes that can take a little bit of time. And I leverage environment variables pretty heavily throughout my demo. So you can see location is central US, and you can see when I highlight it, the multiple times that I use location just to leverage the environment variables. The resource group name is just practical container scenarios. I create a resource group and verify that it's there. So let me go ahead and highlight this, run that. The group, the resource group's already created. So if I do a AZ group show, we'll see that hopefully, it's like the first time, there we go. You can see that the provisioning state has succeeded, so our resource group is available to us. Now, I've gone ahead also and created our ACR previously, our Azure Container Registry, because sometimes that can take a little bit of time. And so let's go ahead and do an AZ ACR show to see if our container registry is available. and it is. We see it's up and running, and it's available at this URL here, centinosystems.azurecr.io. So I have a container registry in Azure, and I have a container locally, and I need to get my local container up into my container registry, where I would normally do a Docker push into ACR, which would ship the whole image into ACR, but we kind of have a way that we can get around that with some optimizations with how Microsoft has exposed Azure Container Registry. Rather than shipping the whole container image, I can say use a particular Docker file and build the container in ACR. So I'm going to say ACR build. I'm going to build this image. I'm going to name it my web app image with a tag of v1. I'm going to send it into the registry, which is my ACR name, and it's going to look at the relative path for the Docker file in a location that we're already in. So what's going to happen is it's just going to ship the Docker file and the required code into Azure, which is just a couple megabytes. I don't have to ship the whole container. So behind the scenes, it takes my code, zips it up, sends it into Azure, gets it into Azure, expands it, stands up a container to build my application, throws that container away, and builds my permanent container and stores that in ACR for me, which is pretty cool to be able to just to get that optimization. So here you can see sending build context, the Docker container was only 13.97 megabytes. That's a lot less than having to ship the whole 200 megabyte container that I would have. So now we can see the similar output that we saw a second ago, executing that Docker file to build the container image inside Azure. And here you can see it's preparing, pushed, it's pushing the container into ACR to store it permanently, and it's going to store it in this location here, centinosystems.azurecr.io. And later on, when I need to reference that container, that's the path that I'll use. So let's switch back over to the presentation and learn how we can leverage what we just did. So we created a container locally, right? The container-based application in Docker. We started it up and ran it, looked at it locally. Then we took it and built it in ACR, right? In Azure Container Registry. It's just sitting there now. We don't have any running applications yet, because now we need to talk about deploying container-based applications for real, right? And how we're going to do this in our data centers. It's great to be able to do it on our workstation in Docker, but how do we get this? How do we solve these problems in our enterprise applications? So let's talk about why or how things changed over the last couple of years in how people build or how developers build applications. Historically, we would see things like single-tiered applications. Jokingly, it's like anything written by IBM, right? These big monolithic systems that run inside of banks and like airlines and things like that, jokingly. But single-tier applications, that whenever I had to service that app, well, I had to service the whole thing, right? This giant monolithic application. So after that, we kind of saw multi-tier applications. So things like service-oriented architectures, client-server applications came along and kind of localized to where we could service our applications. I could service maybe like this piece here and push that code out, or I service this piece here and push that code out. And as long as I respected the contract of that, the data that needed to come in and out, things worked great. But even that was kind of hard to do. And I kind of talked about earlier, it takes a long time to get that kind of application up and running in a data center. And over the last couple of years, we've seen a shift to this thing called microservices, right? A microservices-based architecture, which really kind of extended that concept of drilling down to smaller, more easily changed units, right? And that's where containers come in, is we kind of focus into these individual units that we service those individual units, and we can roll things out faster, right? So these microservices, as long as they provide the functionality that they need, we can change these little bits and pieces in our data centers very, very easily in getting code out. And so that kind of meant we had some challenges to solve, though, in how we rolled these things out. Like if I have an application that looked like this, where I had some web servers, a caching tier, and a SQL server, that kind of gives me some challenges that I have to solve when I want to run these things as containers in my data center, right? Those small, easily changed units. Like, what do I do? Like, how do I get these things up and running in my data center? Like, where do they actually execute? Are they executing on VMs, hardware? Where do I get those things running in my data center? How do I scale this application? What if I need to go from 2 web servers to 20 to support a burst in workload? How do I consistently deploy my applications in this data center, or maybe in a DR data center, or maybe in a cloud or a second cloud? How do I solve that problem? How do I consistently roll out my apps? I don't want to get in the business of having someone do Docker run on a bunch of individual instances in my data center, because that's very error prone. And how do I provide consistent services in kind of this loosely connected system? We talked about killing things and redeploying things and getting applications rolled out quickly. Well, how do I tell which applications to point to where? How does the web server know to point to that SQL server, or how does the web server know how to point to that caching server, or the caching server to point to the SQL server? How do I provide that consistent service to consume in that model of killing things and redeploying things? And that's where container orchestration comes in. Container orchestration attacks those challenges. And the primary thing that container orchestrators do is workload placement. Where do I run a container in my data center? On what hardware? Do I have enough capacity to do these things? That's kind of the core function of a container orchestrator. Its job is to start up a container and get it up and running and figure out where to run it in my data center. It also has the job of managing state, starting things up and keeping them up. If I tell a container orchestrator to keep an application online and that application crashes, well, a container orchestrator is going to react and make sure that that application is up and running somewhere in my data center. We're going to learn about those techniques in a little bit. Container orchestrators provide networking and services, right? They expose our applications on persistent IPs and ports. We don't have to get into business like we did a second ago of saying, well, this app runs on port 80 and I want to expose it on port 8080. I define that elsewhere. I don't define it in the container. I define that in the container orchestrator. We're going to look at some sample definitions of those today. Container orchestrators provide load balancing. Again, if I need to go from 1 to 2 to 20, how do I distribute that workload? The container orchestrator can manage that for me. They also provide persistent storage. So if we're talking about database systems, I can have persistent storage exposed into my container-based applications. And they also provide this thing called a declarative model. If you've ever gotten into the business of configuring a server and you execute sequences of commands to get your server into the desired state, that's imperative configuration. With a declarative configuration or declarative model, I tell my container orchestrator what I want it to do. I don't tell it how to do it. I leave that up to the container orchestrator. I just say, hey, run these 4 containers, give me a public IP address, let me know what that is when you're done. Just get my application up and running for me, right? Figure out where to run it, figure out what storage it needs, and just make that happen. And we write some code that defines what we want that system to look like, and that we do that in what's called a declarative configuration model. And we'll look at some samples of that in a second. Now, those are the concepts of container orchestrators, right? Or excuse me, that's the concepts of container orchestration. Let's look at some container orchestrators, like the actual products that are available or technologies that are available to do this work for us. There's Docker Swarm, there's Kubernetes, Red Hat OpenShift are the big players in this universe, right? So Docker Swarm is from Docker, it's a container orchestrator. Kubernetes is an open source platform that we'll look at today that is a container orchestrator. And Red Hat OpenShift is Red Hat's branded and supported version of Kubernetes. Now, there are some managed services, and we're going to focus on this one today, AKS, or Azure Kubernetes Service. We can tell Azure, hey, I want you to run a Kubernetes cluster for me. And with that, I'm going to deploy some applications in there. And we're going to do that together in a demonstration. There's other container orchestrators available, GKE from Google and EKS from Amazon. So I used the term a second ago, Kubernetes cluster. You're like, what's that? Well, let's get through what a Kubernetes cluster is. What a Kubernetes cluster is kind of an overlay of the hardware in my data center. My cluster of servers, like literally the computers themselves or virtual machines, can be aggregated together from a resource standpoint. And Kubernetes, the container orchestrator, figures out where to run the workload in that cluster or that collection of physical machines or virtual machines or those resources that are available to it. And so when I tell Kubernetes to do something like stand up an application, it's going to go ahead and do that for me. It's going to place the workload in the cluster in a way that is aware of the resources that are needed to run my application. Do I need public IPs? Do I need storage? How much RAM or CPU that I need? It's going to make those scheduling decisions for me on where to run my containers in the cluster. AKS, which is the one that we're going to focus on today, is a managed cluster. So what that means is I can go like other types of managed services that are in Azure. I don't have to really get into the nitty gritty of stitching together a Kubernetes cluster. I can just, hey, Azure, create a Kubernetes cluster for me, and then I can consume that as a service, which allows me to handle things like upgrades and all that complexity. Again, that's all managed by Azure for us. And so I'll have this thing where I can deploy workloads in just a matter of minutes in AKS or GKE or any of the other managed services that are available. When we build an AKS cluster, and we're going to do this together, is we define a number of nodes. Like there are actual VMs behind the scenes in AKS that support the workload. And so we say, I want to run this number of nodes, or in Azure parlance, agents. We start off, if we don't define a parameter, we'll get 3, but we can scale that to 3 to 4 to 10 to 100, whatever it is that we need to support the workloads inside of Azure, right? And how do I know how many nodes that I need? Well, that depends on the application that you're running, how much resources are being consumed in your apps. Nodes are deployed in Azure availability sets. So if something goes bump in the night, or if they're completely isolated from that standpoint, patching and things like that. So you get the resiliency of availability sets inside of Azure. So we talked about the declarative model, right? How I want to tell Kubernetes, I want you to do these things for me, right? Or how I tell container orchestrators that I want you to do these things for me. Run this container, run this many copies of this container, assign this storage, give me a public IP. And we don't do that by executing a sequence of commands. We're going to write code that describes our system, right, in a declarative model. And so Kubernetes exposes an API, or a collection of API objects that represent the resources in our system that we have to deploy. And so what this really is an API over the resources in our cluster, and we define the workload that we want to deploy in code. Now, the primary constructs that we're going to use to define what we want to run in Kubernetes are things like pods, controllers, and services. Right? These are kind of the core elements to get things up and running. What's a pod? Well, it's your container-based application, right? So the thing that we just built and we stuck in ACR, we're actually going to take that and define it as a pod inside of Kubernetes, and Kubernetes is going to deploy that into our cluster for us. Then we have controllers, which help us maintain a desired state. We talked about a second ago, if I tell Kubernetes to stand up 4 web servers or 2 web servers or whatever it is, if something goes bump in the night and we skew away from that, let's say we go from 2 web servers down to 1 because of an application crash or a node crash that was running our container, well, Kubernetes will figure that out and deploy another container, which is very valuable from an availability standpoint. Controllers can also manage scale. So I can say I want to run 1, 10, or 100 pods of a particular application very, very easily. And we're going to do that in some demos. Services provide persistent access to our apps, right? So I'm going to wrap a service around a collection of pods, which is going to get a persistent IP, and Kubernetes is going to load balance that work to the pods or the containers that are running our application, right? Very valuable concepts there. Since we're DBAs, we care a lot about storage. We can ask Kubernetes to take some storage from the cluster and attach it to a container. And we can tell it to do that over time. So if a container dies, goes away, or comes back, it'll figure out it needs to attach that storage to that container and get our application back up and running. And that's how we can provide persistent data services inside of Kubernetes or inside of containers. These are the core building blocks of apps, right? We have our applications and pods, right? We define the state and controllers. We get access to those via services. And if we need storage, we can have persistent storage for our apps. But there's lots more API objects available to us to build and model the workloads that we need inside of Kubernetes. So let's talk a little bit more about services and this concept called replica sets. And we're going to look at our cluster again. And if I need to deploy an application, I say, hey, Kubernetes, I want you to run some number of pods for this particular app. And the API object that I'm going to do that is a thing called a replica set. So when I define a replica set, I give it a number of pods that I want it to run. So in this case here, we see we have 4 pods running in this replica set. So what Kubernetes will do is start up the replica set, realize that I told it I needed to run 4 pods or 4 containers of this particular application, and get them up and running, schedule them, and put them into the cluster somewhere, right? And wherever the resources are that are available. We then want to define what's called a service, right? We talked about controllers. Well, a replica set is a type of controller. And then we define a service to get access to those applications that are running in those pods. The service is going to be something like this, HTTP. And that's going to be a persistent IP listening on port 80 that's going to expose the application to my end users. Now I point all my end users to this service, and then Kubernetes will distribute the workload to the pods that are a member of the replica set. And so that way I get load balancing. I also get application resilience, because if this pod goes bump at the night or the node that it was running on dies, Kubernetes will realize that it's no longer available. And since I told it to run 4 of this particular pod, what it's going to do is deregister that pod from the load balancer and stand up a new pod and re-register and register that pod into the load balancer and start distributing workload to it. That's a crazy amount of tech to do something that's really hard to do in a data center. If you've ever built a managed web farm and you see the functionality that you get out of this particular piece of technology here, it's pretty impressive to have that just self-heal itself when your application dies. And you can get really intelligent into how these things work with things like application probes to define, is this application really healthy? So there's readiness probes and liveness probes are the technologies there to do that. So nobody actually deploys replica sets directly. You deploy a thing called a deployment. And so deployments deploy replica sets, and we'll talk about how that stitches together now. Deployments are used to provide declarative updates to pods in replica sets. And that sounds really fancy, but what it really means is I can say, hey, Kubernetes, run this version of my application. And and it's going to stand up a replica set like we just talked about for that app. But then when I need to switch to version 2 of my application, I can say, hey, Kubernetes, switch from V1 to V2 and manage the way that that gets rolled out. And it's going to take that and just move the workload between the 2 replica sets. And so like I said a second ago, deployments are made of replica sets, and deployments manage the transition between replica sets. Deployments are also used for scaling our application, which we can do manually. I can go from 1 to 10 to 100 very, very easily if the resources are available. And I can also scale on a resource consumption. So if something goes crazy in your application, and next thing you know, you're getting a huge surge in workload, well, you might actually not have to do anything. You can tell Kubernetes, when my CPU gets to 50%, kick out 5 new pods, because I know that I have the resources to support that run up in workload. Well, just make that happen for me, and it'll do it. It's a really, really cool piece of technology there. And so let's talk about, get a visualization of how deployments really work. And so we talked a second ago that deployments are made of replica sets. So if I define a deployment inside of Kubernetes, it's going to instantiate a replica set. In this case, let's say I define a deployment running a particular container image of version 1 of my application. Kubernetes will stand that up, run the replica set. I front end my application with a service, and I point my users at that app, right? So everyone's happy. Version 1 of my application is up and running. Now the developers come along and they publish version 2 of the application in our container registry, and I get to go ahead to roll this out, or I built a fancy CI/CD pipeline, and this could happen automatically for you. What's going to happen now is we'll tell Kubernetes, I need you to switch from the container image V1 to the container image V2 that's currently available in our container registry. And what Kubernetes will do is we'll stand up a new replica set and start shutting down the pods in the old replica set and start deploying the new pods in this new replica set of our version 2 application. As the V1 pods got shut down, they get deregistered from the load balancer. As the V2 pods stand up, they'll get registered in the load balancer, and I just upgraded my application. Now, if you notice, I left the old replica set up and running, or excuse me, the definition is still on the screen, because if I need to, I can tell Kubernetes to roll back, and it'll go from V2 back to V1 because the metadata for that replica set is still available to me for a period of time. That's another crazy piece of technology. I can move real time between V1 and V2 of my application with 0 downtime, right? Users are hitting the service. Kubernetes makes sure that there's a number of pods always available, whether it be old or new, and I can manage the transition between the two. Now, you're probably thinking application state and things like that. There's lots of knobs and buttons that we can turn inside of deployments available to us to make sure that that transition is smooth. This is kind of the core concepts behind that. And so application deployment in Kubernetes, imperative, big deal, or not generally how we're going to deploy applications in Kubernetes, but let's talk about how to do that. So if we want to stand up a workload really, really quick, and we want to run that application that we built and stored at ACR a few minutes ago, I can say kubectl run my web app and run this container image. And here you can see it's the path to the container image that we built together in the previous demo. Now, kubectl is the command line tool that I'll use to interface with Kubernetes. In this case, I'm just saying, hey, Kubernetes, run my web app with this image. But that's not how we're going to do things, but we can. It's great for demos. But we want to do things declaratively. We want to define our desired state in code. And we do that with this thing called a manifest. And that manifest is going to be code that's either going to be YAML or JSON, depending on, basically, if you're a human, you're going to use YAML. And if you're a computer, you're going to use JSON. And then we say Kubernetes, I want you to, kubectl, I want you to apply -f, a file, the code that's in the deployment.yaml file. And inside of that deployment.yaml will be the definition of what we want Kubernetes to run. And so let's go ahead and do that together. We're going to declaratively deploy an application in AKS with deployments. We're going to front end it with a service, and we're going to take that application and scale it from 1 to 50 replicas very, very quickly. All right, so where we left off was making that image, and we're going to take that image and roll it out into our cluster. I have some environment variables here that I want to set. So let's go ahead and run those. One is basically my cluster name. So here you see AKS minus practical container scenarios. And I'm also asking Kubernetes, or excuse me, I'm asking Azure for the version of Kubernetes that's available for me inside of AKS. And then we're going to use 1.13.7. There's multiple versions of Kubernetes that are available. And in this case, I'm getting the latest one. Now, I've gone ahead and created our cluster already, but I have the code here for you to do that. We say AZ AKS create, we define the resource group, we give it a name, a location, specify a version, which is why I pulled that version, and the option generate SSH keys. This is going to stand up a 3-node cluster with 2 vCPUs and 7 gigs of RAM each, right? So that's going to be the cluster that we're going to deploy our applications into, right? That takes a few minutes, so I went ahead and did that before our session today. And so if I want to ask Azure as to AZ AKS show, and I want to ask it to just see what the status of my cluster is. And so here we can see we have our count is 3. The maximum of pods that we can run is 110. Each individual VM has a 100 gig disk. It's running Linux, it's running managed disks, and it's this VM size. You can specify different VM size as an option if that's something that you need to do, but we know that our cluster's there, so let's go ahead and break out of that. Now, I need to kind of bolt 2 things together right here. I need to tell my ACR, my container registry, that I want to allow my Kubernetes cluster to read from it. And so that's what these 3 lines do here. I get the client ID for my container registry. Excuse me, the cluster, not the container registry. Come on, Azure, you can do it. You can do it. Don't worry, I have video demos as backup if this gets dicey. Oh, there we go, good. All right, so this was the ID for my Kubernetes cluster. This is the ID for my container registry. And I'm going to create a role assignment between the 2, right? And what this is effectively doing is saying the role assignment already exists, is saying that my Kubernetes cluster can read from the container registry because I want it to be able to automatically pull those container images down. Now, kubectl, it was the command line utility for me to work with Kubernetes, is available, can be downloaded and installed this way. I just ask Azure CLI to give me install CLI, and it'll install Kubernetes for me. Now, I need to be able to authenticate and locate my cluster. And the way that that works in Kubernetes is with this thing called a context. And inside the context, we'll have the location of our cluster, right, where it lives physically, like its actual location on the internet, not like physically, sorry. My username to work with the cluster, and an authentication method, which in this case is going to be certificates. And so I go ahead and run that code, and it brings it down. Now, when I want to, before I get started, I want to kind of just check the plumbing, right? We created a cluster, we created this role assignment, I have these credentials, and I just want to test the plumbing to make sure that this is going to work well. And here we can see that it did. So I said kubectl, right? The command line utility to work with Kubernetes. Just give me your cluster info. I just want to make sure you're there. And inside of there, we can see that our Kubernetes master is running at this location inside of Azure, right? And I can ask Kubernetes, hey, Kubernetes, what are the nodes or what are the servers that are available for me to deploy workload on? And there's the 3 VMs that back end this particular cluster. And so here we can see 0, 1, and 2, they're up and ready. Their roles are agents, and they've been up for about 3.5 hours. Now, I'm going to do 2 things. I'm going to go ahead and run these 2 pieces of code, and then I'm going to jump over to those YAML files and talk about what's inside of those. Well, let's go ahead and start with the deployment. So this is the API object that we talked about a second ago in the presentation portion, where I say, Kubernetes, I want you to run this number of my application using this container image and expose it as a service. And so here, for all Kubernetes objects, we'll need 4 pieces of information. We'll need an API version, a kind, metadata, and a spec, right, or the definition of the object that we're working with. And so the object type is deployment, right? We're saying, Kubernetes, I need you to create a deployment. I'm going to give it a name, web app dash deployment. And inside the spec is where I tell it what I want it to do. I say run one replica of my application, and I want you to run this application. So I say spec, this is the container that I'm going to run. I'm going to give it a name, and then there's the image that we're going to use, right? This is the image that we created earlier in the session, and it's going to run on port 80, right? That container application is exposed on port 80 inside the container. Now that's not where I'm going to point my users to, but that's where that application is actually listening. So I take this, and like I did a second ago, I say kubectl apply, and Kubernetes will make that happen, right? I didn't tell it what to do. I just said what I want it to do. I want you to run this one application from this container image in my cluster. Now I front end that with a service. And so here's, again, all Kubernetes YAML files need 4 things: API version, kind, metadata, and spec. So the kind is the service. I give it a name, and I give it a spec, right? The definition of the thing that I want. In this case, we're using a service. So this is going to be the persistent place that I'm going to point my end users to, right? Or other applications that might need to consume whatever it is located here. I'm going to expose that on port 80 on port TCP, right? I could put HTTP there if I needed to for the text right here, but I like to put the actual numeric value. I'm going to send the traffic to port 80 inside the container. And in this case, the type of service that we're going to deploy is a load balancer. So I'm going to have a persistent IP at that, or inside of Azure, that I'm going to point my users to, and it's going to distribute that workload to the members of the deployment. And so once that's all up and running, I'm going to go ahead and check the status of what we have in our cluster. And the way that we do that is, after we deploy the applications, we can use kubectl to get information about an object, right? The deployment type. So when I run that code, I get this output here. I see web app deployment, which is what the name of our deployment. We see that one container is up to date and available, right? And this was stood up just 2 minutes ago. So our web application is literally up and running inside of Azure based on what we defined inside of that deployment.yaml. Let's go ahead and run this here so you can see our deployment is made of a replica set. In this case, here we can see that this is the actual application that's running, where the deployment is going to manage the distribution of the work, or manage the state of the deployment of my application. Now the individual pods behind that replica set, right, we only defined one in our deployment.yaml. So there's only one pod up and running and supporting our application, but we can point our users to the service and it'll get load balanced just to that one pod. So let's go ahead and test out our application. So here I'm using the command kubectl get service, which is going to tell me the public IP of my application, so 52.165 and so on, what it's listening on port 80, and where it's sending the traffic to. And so I run this bit of code here to store that as an environment variable, because this can change based on the number of times I do this demonstration. And then I can run curl, which is a command line web browser, and see that my system host name, right? I'm just hitting the web server and pulling out the host name of this particular application. And we can see that the system host name is the same as the pod name that we looked at a second ago. That's one of the reasons why I wrote the code that way, so we can kind of see where these things are living inside of our cluster. Now, if I want, I need, having one pod up and running isn't really scalable, redundant, all that fun stuff. So let's go ahead and deploy 10 pods. And I can do this that fast. I say kubectl scale. What do I want to scale? I want to scale my deployment and the name of the deployment, and I tell it the number of replicas that I want. I just switched it up to 10. So now if I do kubectl get pods, we'll see I have 10 pods up and running and supporting my workload in my cluster, all being load balanced to, and I did that with one line of code, right? That's the power of declarative configuration and Kubernetes and containers. If you had to do this in, like I said, the olden days. If you ever built a web farm and you had to clone images and things like that and deploy workloads as virtual machines, that wasn't fun to do. You can do this now in very, very simple one line of code. If I want to go even crazier, 50, I can do that too. And we'll see it's the job of Kubernetes to just make that happen. So behind the scenes, we'll see our containers that were up and running in the first deployment. It's going to be creating the containers. Some are still pending and haven't gotten started up yet. But by the time I do this a couple times more, you'll see that we shift into fully functioning running containers very, very quickly. That's 50 containers supporting our workload in our cluster. So 50 independent instances of our application up and running inside of Kubernetes. And if I go and I hit that web service again, we'll see that I'm automatically getting load balanced to all the different pods in our service by looking at the host name that comes back. And we can see that it's hitting different pods because they each have a unique identifier for the host name inside of the application. Crazy, crazy powerful stuff there to help us get work done. So we did it. We deployed declaratively applications inside of AKS. We did a deployment and we exposed that deployment with the service, and we went from 1 to 10 to 50 replicas very, very quickly. So what's next, right? We've built this infrastructure, right? We can very quickly deploy applications into AKS or even EKS or GKE, wherever we deploy Kubernetes. And honestly, in on-prem too. I think we can also deploy Kubernetes on-prem in servers in our data center. Well, what's next in doing all of this? Well, in that particular application stack, I'm just spitting out host names, right? So there's not a lot going on there. But I might want to build a data tier, meaning I could have database services up and running. I could put a container, expose it with a service, attach some storage, and send users to SQL Server running in a container. I want to be able to handle database connections and connection strings dynamically. Well, I can push that into my configuration of either my YAML that describes my container or store that kind of stuff in Azure Key Vault and other configuration management tools. We want to build a production ready app tier. What we did today was cool, right? You kind of saw the plumbing, but that's not really like how we do this for real. If we're deploying container-based applications, you know, like I said, we deploy things using Azure Key Vault, like connection strings. We'd have SSL termination to perimeter with application gateways or ingress controllers, which is a way for Kubernetes to expose its web services to the world securely and efficiently. We also want to look at building some DevOps pipelines that might automatically build container images and roll that stuff out into our Kubernetes clusters for us automatically, leveraging tools like Azure DevOps, right? So these are kind of the things that we do once we kind of get our feet wet with building a container and deploying it in AKS. These are the next level things that we'd want to look at to get this going for real. So more resources. Where do you go next to learn more about containers and Kubernetes and things like that? The first stop that I would make, if you haven't done this before, is go ahead and get Docker for Windows or Docker for Mac. And I have some links at the end of the session to show you how to install that. Minikube is a way to run a Kubernetes cluster on your local laptop, which will allow you to very quickly get Kubernetes up and running locally. I actually prefer to use Docker for Mac or Docker for Windows, which has a Kubernetes cluster built in itself as well. So either one of those can get you where you want to be, but I prefer Docker for Windows or Docker for Mac to help me with that. The managed service providers, you can very quickly get a Kubernetes cluster up with AKS. Here's a link to get that going. We walked through those steps together today. Pluralsight, I have some courses out there on Pluralsight, both for installing and configuring Kubernetes, both on-prem and in the cloud. That's all covered there. And I also have a course out on building workloads inside of Kubernetes for API server and pods. And again, not that I want you to go buy these courses. If you want, send me an email and I'll give you a 30-day trial code so you can get access to that content for free, because it's covered in a lot more detail in those courses. So just to review, kind of went through some big element items. We did container fundamentals. We created a container together. We put it in ACR and we deployed it in AKS, right? A lot of work in a short amount of time, but that's kind of the power of this tech, right? We took source code, containerized it, and deployed 50 replicas of it in less than an hour. And that, I think, is how we'll be building systems for the foreseeable future, both in a data platform and in data centers and in the cloud. So here's my contact info. Like I said, if you want a free trial card, hit me up. I'll put the talk at that URL location there. And I'll also give it to Tom for distribution. But if you have any questions now, or if you want to email me later, please feel free to do so. So Tom, is there any questions that we want to get through?
Anthony, there's no questions in the queue. We'll give them a moment to see if anybody posts anything. Thanks for coming by and giving us more information, teaching us a little bit about Kubernetes and orchestration and stuff like that. That's really good stuff that we're going to have to know. So
Right.
the DBA's world is expanding. So
that it is.
That it is. I don't see any questions coming in. Someone just said thank you for it. So
thank you for coming.
We will actually see you next week. So
cool.
Have a great day and talk to you later.
Cool. Thank you.
Bye-bye.